Hello and welcome. Okay, so yeah, in our first session, we talked a lot about like developer speed in terms of being able to, make changes to your site, add new features more quickly. This session, we're going to be talking about site performance, like site speed. Okay. And again, we'll do a quick intro, just in case you weren't here before. My name is Sara Carothers. I lead the product team that focuses on experience products, everything really related to the reader and user experience, like Page Builder, your website, our CDN stack, and our mobile SDKs and themes. And Fatih?
My name is Fatih Yildiz. I'm a technical product manager on Page Builder engine team, but I also oversee developer experience holistically.
Okay, so give you a little preview about what we're going to plan to talk about in this session. First, I'll just share some data, some industry benchmarks, especially like in the media and publishing industry for site performance, and kind of talk about some of the common challenges that we see all of our customers dealing with, or most of them at least. Fatih is going to talk about some technical optimization strategies to improve your site performance. And I'm going to then kind of get into tactics that are a little more cultural or like organizational for having, tough conversations internally with your stakeholders, managing trade-offs in order to make site performance improvements. And then last, we'll talk about some of the tools we have available or other tools you can use to continue, monitoring your performance and stay on top of it. So I want to start with some industry benchmarks, really look into like what is average for site performance in the media and publishing industry, and dig in a little bit into why that is. So I don't think this will surprise anybody. This was a study of Lighthouse performance scores across 1,600 different news sites. Lighthouse, if you're not familiar with it, is a Google test, an automated lab simulated test for performance. They give you a number 0 to 100. They consider 90 and above to be good. It's not a perfect metric, but because, like I said, it is simulated, it's kind of worst case scenario, the slowest internet, the oldest phone that a user might be visiting your site on, but it's helpful for comparison tools. So yeah, Google recommends over 90. The average on home pages was 54, or no, sorry, the average on article pages was 54, the average on home pages was 24. This was, sorry, I'm covering this up here, a study from the University of Missouri's Journalism School. Here's a second one. This is looking at, I think, over 1,000 news websites. Both of these were global news sites, looking at sites across the world, not just US. And this is from a project that's really great to check out. Ben Welsh, who now works at Reuters. It's called the News Homepage Project. By the way, I should have mentioned this. We will send out some links, for like docs and things from our slides. You'll get an email like after the conference with some things that'll be helpful. Anyway, I wanted to bring this up. It's another example. The average performance score or the median is 35 here. And you can see that like most of the scores for the sites are concentrated like 0 to 40. That's, like I said, kind of the baseline, kind of the average. But there are a couple way over on the right here, and like really just a handful that score over 90, which is what, again, Google judges as quote unquote good. So I kind of wanted to look at these, like how do news websites manage to achieve over 90 in Lighthouse performance scores when it's clearly very difficult to do. So this is one of the top performers in that survey. It gets a 98 out of 100 on Lighthouse. This is another example from the top 10. It gets a 96 out of 100. So we're just going to kind of look at these, and now I'll go towards like the bottom of the list and see if we spot patterns. So this is a site I think one at the bottom, it scores a 2 out of 100. This is another one that scores a 2. And just want to kind of think about like what's different about these sites from like the top performers. And if it didn't jump out at you, would be the advertisements. These sites at the bottom do run ads, but actually all the sites like in the top 10, the ones that are scoring over 90 on that survey, don't run ads. Their business model doesn't have ads involved. They run on donations. So you'll notice a donate button up here on this site that scored 98. This one that scored 96 also has a donate button, 100% reader funded. There's no ads on this site. So obviously, that's not a realistic business model for most publishers. Like ads are really critical. But I think it also kind of speaks to the challenge that we have working with ads and how it's really easy for them to kind of impact the site performance. So let's look a little bit more about like what exactly is it with ads that can really harm performance. This is another study from Pingdom. Sorry, I'm covering this up a little. Looking at top 50 news websites worldwide and how many, third-party tags, trackers, beacons, or pixels do they load. The average news site has 43. And, there's definitely ways to like optimize the way that these are loaded. But at the end of the day, it is JavaScript that's coming to the user's browser, and it can really hamper site performance. The vast majority of those trackers are for advertising, although there are some for other purposes, a general tag manager, which actually may be calling more of the advertising tags or analytics tags. There are tags that are just for analytics, but really the vast majority of the tags are advertising. And so that's a lot of code for the browser. I'm not trying to pick on ads specifically. It's just that typically to run ads, you need, you start using a lot of different ad tech vendors, and they all need their own script, and it needs to get on the site. So there just ends up being a lot of JavaScript. JavaScript is expensive, of course, no matter what it's for. It's just in the media industry, I think, the one that we see the most challenge with is advertising. This is going back to those examples I showed before of like the sites that scored really high versus the sites that scored really low. Those two high-performing sites, one of them only has 2 tags, one has 8 tags, and then on the other end of the spectrum, this site has 139 different tags that are loading, and this one has 140. These are really an extreme example, and so before I worked on the product team at ARC, I worked with our professional services team at the time. I did a lot of, working with customers to build out their site. And I kind of see this as like a symptom of sometimes like the tags just get out of hand. And what we would find a lot of the time, when you're going through rebuilding your site from scratch, sometimes you have to do an inventory, and you're trying to understand, all right, we have this JavaScript on our old site. What's it for? Who uses it? So often we would, kind of have to do almost like an anthropological study to figure out who added this. Maybe they've since left the company, but the tags might stick around on the site. So like I said, I think this is an extreme example. It's possible to run ads and not have your performance be this low, but this is kind of what can happen if it goes kind of unchecked. So just some takeaways from this. First, I think obviously ads are critical to the business model for publishers. We have to work with them, but they can use a lot of JavaScript. Like I said, it can kind of build up over time, and that can negatively impact performance. So for that reason, ads are important. We want to cut costs, for lack of a better term, cut our site size every other way we possibly can. Fatih is going to talk about some of those strategies next. And then the last point, which like I said, I'm going to come back and talk about after that, is like sometimes it's not just technical teams that can improve the site performance. It really has to be like a cross-organizational goal, you know, with design and editorial and revenue, all understanding like the importance of performance and having tough conversations about like what is absolutely required to load. So I'll talk about some strategies we've seen that help, you know, get those conversations started, keep them on track, and then also, you know, talk a little bit about like this is going to become an even more important conversation to have as third-party cookies are deprecated. A lot of those ad tags, you know, a lot of the benefit they provide is the third-party cookies that track the users across the internet. If those are no longer providing value, it'll be time to take them off your site. But, you know. So that's just something to kind of keep in mind. So yeah, now I'll hand it over to Fatih, who's going to talk a little bit more about some technical optimization strategies.
Sarah mentioned something that every millisecond counts. It's a budgeting practice that, since you cannot compromise on your business model, you need to find like every possible technique to minimize your render performance, right? So I'm going to be covering those more technical strategies, and Sarah covering, you know, more on the strategy front, like organizational changes. So where to start? This is definitely arc flavor. There are different buckets to, you know, be aware of. I'm going to highlight a few other areas, and we're going to minimize some of them because it's not the first concern or first place to start. They're probably more like, you know, extreme optimizations that you need to look into. So this kind of maps out like how your page gets rendered from kind of like arc side to the point that it gets distributed globally on our edge network at CDN with, you know, multiple layers of cache that will end up being in, you know, your user's browser. And browser does like a million things to, you know, present your website to your users, right? Ads are usually client-side initiated integrations. That is probably why, you know, the lot of JavaScript. There's also, you know, a lot of like weird techniques that ad networks abuse. Matt, earlier in the day, you know, cookies weren't designed to, you know, be used for advertising technologies, but it's been overly, you know, used. Similarly, iframes. There's a lot of like, you know, so it's combination of things that results your, you know, page render to be blocked and your user to, until your users see your content. In some cases, Google catch you and, you know, penalize your, you know, scores. That will impact your, you know, SEO scores, and, you know, pretty much like your reader experience is also going to be impacted directly. So just because we do have a CDN layer, that is, its job is to answer scale, like traffic at scale. So your pages that receive frequent enough traffic, they, you know, CDN generally masks the problem. If you have problems on the server-side render, let's say you use expensive APIs to render your page, that expensive operation is most of the time is not going to manifest itself in end user, because that page will be cached and your users will be receiving like cached content in most cases. But there's an edge case that we're going to come back at the end, that it's not, you know, CDN covers your mistakes, so you shouldn't care about server-side render. You should care about it, but it's probably the last area you should look on. So majority of our tactics that we're going to talk about is going to cover what happens on the browser side, whether your client-side render you know, has large bundle size, or your HTML, you know, document itself has, you know, artifacts that you may not be needing or utilizing it on the client-side render. And there are some like out-of-box solutions that Page Builder, you know, comes with that you can utilize to minimize some of these, you know, impacts on the reader's experience. And there's also, you know, Page Builder is designed, architected in a way to refresh the content on client-side render with a second render phase to make sure like we're serving fresh content, even if your server-side render was, you know, created with a cache that sits in the Page Builder side, not at the CDN side. So we're going to be talking about some techniques to overcome some of those. If you can tolerate, you know, some pieces of content can stay stale for 2 minutes, or maybe an hour, or perhaps even longer, that will surface itself in performance optimizations in certain areas. So I'm gonna cover like 7 different tactics. We don't have to read the slides because we're gonna go each one by one. And again, most of them are gonna be on client-side render. So probably the best place to start is analyzing what is your current state, because most of you guys are already you created your digital experiences, and I'm happy to see a lot of you guys are concerned and working for improving your page performance. The techniques that we will be touching in this session, I'm sure most of you guys are heard or already implemented them, but awareness is key, and it's important to understand what goes where when you make a decision, development decision, to choose a dependency to render a content in a certain way. It can be an interactive component that has like an interactive map. For election, we've been using election as a sort of like an expensive example, but it is. Or it can be a static function, but it may be using a dependency that may be really costly that you are not aware of. We have some examples we're going to touch on, but it's important to understand what goes into when you include new things in your bundle, what goes where. Server-side render creates a service, is rendered by a server-side bundle, which is built when you deploy a bundle, when you upload into deployer. These different pieces are created at the build time, most of them, right? Server-side bundle will contain pieces like engine core. There's not much you can do about if you're utilizing engine capabilities unless you are completely stripping engine. And it's possible in one of the extreme examples that we're going to give. Dependencies, pretty much like every dependency you use on your feature blocks, but you shouldn't be concerned too much about it because your server-side bundle being 10 megabyte versus 200 megabyte is not going to make big difference on your server-side render time. It's important to know that you're using a dependency only for server-side render, so you to be aware that that doesn't go and leak into client-side bundle, which is going to be waste, right? And eventually static features, which is the example that we talk, you may be utilizing a functionality that may be rendering an SVG map, and that may be it, right? Once it's rendered, it becomes your HTML document, and its job is done. So you to be aware that that dependency belongs only server-side bundle. So when a user requests a page, its server-side render will generate a HTML document. It will include your DOM tree, but also it will include a JavaScript serialized object that can be quite large if you are not optimizing or not being aware of what goes into that big object, which is window.fusion. You can explore this object in command line by yourself, or use Arc Chrome extension that we do have a little bit more, easier to explore those objects. But there are 3 areas that you need to be aware. Your page might include custom fields that may have large HTML embed objects, right? So it's okay. It's to assume that 1 or 2 custom fields wouldn't harm a lot, but in some cases you have like a very big scaled page, like homepage or section front page, may contain many custom fields containing like this raw texts, right? But more importantly, global content, your content source that renders the main content of the page, usually article detail pages or gallery pages or video detail pages, will be embedded in your HTML document, as well as every single feature that uses content sources. Even if it uses same content source but does different query, each query will be cached differently and embedded in your HTML document. So this will impact your early web vital metrics like time to interactive, time to first byte, and some of the render blocking metrics. Minimizing these content pieces will improve those metrics directly, right? And finally, client-side bundle is obviously, it's what engine, packages it for you. And by default, if you are not using code splitting, it's going to be like one large JavaScript file. And it's important to understand what is unused in that bundle code that can be eliminated from any given page. So we're going to be exploring like ways to slice that single bundle file into smaller, chunks and progressively load as your reader explores your, site to different features. So this is a little bit more on the tooling side. Understanding your bundle contents, especially client-side bundle, it's relatively easy. Engine creates a stats.json file that describes your contents of your bundle, and this JSON file can be drag and drop to tools, such as Webpack Bundle Analyzer, to visually analyze what goes into your client-side bundle. This example, you can easily identify like what are the large chunks of dependencies. You can start questioning them. Do we really need this library? Are there any alternatives that is lighter that we can it can do the same job? Perhaps even there are like native functions we don't need that dependency at all, right? We do have that example like Moment.js. It's not tree-shakable. There's no way to optimize on the client-side bundle, even if you use 1% of the functionality included on Moment.js. You're stuck with almost 300 kilobyte cost, right? Luxon is a little bit easier. Date functions, it's tree shaking friendly. You can only point to, what you used in that bundle that will get minimized and effectively minimize your client-side bundle. And there are some tools like, IDA integrations that will help you identify them when you start, including those dependencies in your, bundle. Another strategy, Sarah will talk about this. We will come back to this in a second, but treating your bundle size as with a budget, setting target for it, and obviously those targets can be aggressive, but the goal is to come to that targets that you can afford and monitor that over time to not go over that, because this is a not one-time thing. Once you do it, you need to be aware that this should be part of your deployment practice, that when you make changes in your bundle, you need to be aware that what are you introducing consciously or unconsciously, and what is the cost impact on the reader's experience. It's easy to, there are some automations. This is GitHub like pull request check. You can utilize like a tool like bundle size. You can point out certain artifact that can say like this artifact should be under like 70 kilobytes. And it will block your developer team to not merge the change until conforming those standards. We talk about only bundling the things that you need, and we use like Moment.js. It's a date manipulation or formatting library. Let's say you have an article detail page and you're just parsing published date with some relative timestamp saying that this article published like 2 weeks ago. In order to render that, this is a server-side function. You may be choosing to use unconsciously or consciously Moment.js. It's not tree-shakable, and tree shaking is a technique that when client-side bundle generation happens, the bundlers will detect that only the pieces that you use from these packages and only extract those pieces to be included in your final bundle. And even popular libraries like Moment.js can be not tree shaking friendly. This is a very intricate detail, but it's an important detail because it can cost you a lot without realizing it is. So there are tools command line tools that you can check when you try to shop for a dependency. You can check if that dependency is going to be like compressing or tree shaking friendly. And to demonstrate that, date functions is an alternative. It's a lighter alternative. But if you don't import specific function, and if you only need that, our Webpack bundler will include total 162 kilobytes of the whole dependency in your client-side bundle. But if you're only using this function, this is a screenshot from Bundlephobia. It's a web-based tool. You can search any given dependency. It will tell you if it's tree shaking friendly, which has some requirements. We're not going to get into some technicality of that. But this particular library has individual exports. And if you only include this one, it will cost you 4 kilobytes comparing like 300 kilobyte cost of Moment.js or even smaller alternatives. Doing this further auditing and optimization will give you a lot of room to compress your client-side bundle. Another tactic we want to talk about, using static. So not every single feature needs to be refreshed in client-side render. So some of the dependencies or features or content sources, they're okay to be only rendered server-side, and CDN cache is enough. It's tolerable enough to serve that content within the CDN cache time limits, which is right now it's a fixed 2 minutes, and 2 minutes should be enough for a lot of pieces of content. So to demonstrate what's static and how it functions, we want to show you guys, let's take WashingtonPost.com homepage, and that homepage can have like a lot of pieces of content, can be rendered by different features, and each feature can need and use different content sources to render its content, right? But again, not every single thing has to refresh on the client side. Making this feature static will remove the window.fusion components or parts that is normally will cost you. Also, when the page gets rendered, that pieces of content doesn't need to be refreshed on the client side. So we can think like we can push the boundary to 100. Can we do like 100% static? Yes, some of our clients do it, but we don't suggest it because when you do full static, you lose page builder capabilities like code splitting or other functionalities. So the idea is like finding the balance. When you design a page, you can ask the question that this particular feature does not need to be rendered or refreshed on the client side. If you can make a feature static throughout your bundle or pages, you can even completely remove whatever included in that feature itself from your client-side bundle altogether. Something like election map that we use that expensive example. If that election map can stay still interactive on the client-side render, but if it doesn't need client-side refresh or expensive dependencies that it requires, it can be converted to fully static. So we've seen like 60-70% balance between using converting features static and leaving some of the stuff dynamically rendering is a sweet spot. And another tactic, this is the last one on the client-side bundle, that we talk about. If you don't opt into using code splitting, your client-side bundle will be single package, right? With an example, your user visits your homepage, they will download, let's say like close to 3 megabyte client-side bundle. It will include everything, not only your features for homepage, it will include your travel features, your sports features, election features, everything, right? That user may go to visit sports article detail page, not in this order because we know a lot of traffic comes from the detail pages other way around, but they're not going to download this bundle because it will be cached on the client side, but every single page will try to process it in every time, everything included in these bundle pieces, including the stuff that is not needed for that page. This is going to surface itself in your Lighthouse metrics. It's going to scream that you don't utilize 70% of your JavaScript, like remove unused JavaScript. And tree shaking, code splitting, these are techniques to minimize that. So with code splitting, I'm going to come back to this minimize size, but the idea is you chunk out the features that is specific to experiences used in pages, and they are separated from main bundle. They will not be downloaded until your user gets to those pages. And if your user only are interested in reading sports articles starting from your homepage or other way around, they may not even need to download a lot of pieces that you will be chunking out, and they don't need to use it. Well, this will also surface, manifest as like cost savings for you guys because it's less bandwidth, for you guys, as well as like for users to not download those pieces. Since those pieces are split from your main bundle, your common pieces that needs to be downloaded in every single page will be minimal. You can push this to extreme, but of course, there's no point to make every single feature code split. Finding the balance, understanding like what are the distinct parts of your site, you can split the feature chunks to different code split chunks. This is our initial release benchmarks. The point here is we have seen code splitting when utilized even lightly. It can move the needle for pretty much every single Web Vitals metrics, on average like 20%. Obviously, this is something that for our test bundles, it will highly depending on your what you chunk it out and the total size of your bundle. But this is one of the techniques at your disposal to utilize every millisecond out of your main user experience. So the last point, I want to come back to that CDN, covering your server-side render performance. It's not applicable for some scenarios, and those scenarios might be representing majority of your traffic. I want to start from the right-hand side. These are 3 sample clients that we picked in different sizes. It demonstrates majority of the page renders happen on your long-tail content. Long-tail content are the detail pages, like your article detail pages, gallery, or video detail pages. Majority of your renders goes there. And the reason being, you have content that is written like 2 months ago, maybe 5 years ago, and everything in between, right? Not every content is fresh content that is being refreshed every 2 minutes. So maybe there's an article written 2 months ago that doesn't receive enough frequent traffic throughout the day. So when there's next user comes in, if there wasn't a page render happened within the last 2 minutes that is cached at the CDN, that user will wait for that whole page to be rendered on the server side and to be cached at the CDN. And if that page render takes 1 second, that 1 second will be a burden for all of your metrics, including, and more dangerously, to your crawlers seeing your site's overall traffic. Thinking your traffic, majority of your traffic will be, or your Google crawlers or search engine crawlers will be hitting like everything it knows about your site. They're representing good chunk of that percentages hitting those long tail content. So crawlers will see that low impact on your page performance. So how to improve that? Unfortunately, it's a little bit of a manual process. We're working on self-service version of this capability. But we have done this with a couple of our clients, both on homepage. There are 2 examples, homepage and long tail content. Regardless of the render complexity of your page, we have seen 5 to 10x improvement on one metric that has halo effect to other metrics. And that metric is time to first byte, right? When user hits a page, the time that they start receiving the HTML document from network. That can become like double digits or low triple digits when this improvement is applied. And the point being here, can you tolerate certain pages altogether to be refreshed longer than 2-minute time frame? Answer is, in most cases, for looking at that picture, answer is yes, for long tail content, right? So we're thinking ways to how can we smartly detect like pages that receive high frequency traffic, like our home pages, section front pages, or maybe an article that was written like an hour ago. That will continuously receive a traffic in the logarithmic scale.
Okay, you want to hand me the clicker?
Yes.
Thank you. Okay, all right. So, yeah, like I mentioned at the beginning, there's a lot of technical strategies, engineering teams can take to really try to optimize like every kilobyte, every millisecond. But, often what we see is like you do all of that and there's still other challenges, like I was talking about with the ads, for example, where it's not something like an engineering team can do on their own. It really requires like cross-functional discussions and working towards common performance goals. Sometimes performance gets delegated to engineering, it's the engineer's responsibility to make the site fast. But really, my experience, a lot of experience, like examples I'll talk about to have a really performant site, it has to be a cross-organizational responsibility. Decisions that like the editorial team makes, the product or design team makes, the revenue teams make, also impact performance. Like we talked about ads, also like design decisions. For example, if the design for your website has like a carousel at the top of the page that spins through stories, sometimes that can require a lot of JavaScript. And the designer may not know the impact of that decision unless you've done the work to kind of educate people internally. So yeah, really to make substantial improvements, we've seen that it has to be this kind of cross-functional team. This is a graphic that I think is really helpful to kind of explain this concept. Instead of performance being something that people think about like once you get to the development stage, it really should be something that's a goal from the beginning. If performance is important for your website, make sure that it's part of the conversation when you start any new project. Like, what is the impact of this going to be on our site performance, so that you can think about it through all of these different phases of the project. This visual comes from the source down here, Adi Osmani, who's an engineer at Google. He works on a lot of things related to site performance, has a lot of great documentation about this kind of stuff. So like I said, I'll have links to those, like this article, because I think it's really helpful to frame the discussion. Yeah, and so Fatih also talked about setting a performance budget. And again, this is something that it's a great thing to do as an engineering team, to have it included in your build process. But I also really recommend that you socialize it with the other teams in your organization, and make it like a organization-wide goal to have whatever it is that you guys that you think should be your metrics that you want to hit. I think the budget is a good, it's something that can be easily understood by a lot of teams. Just think of it as like a financial budget. We want to get our time to interactive under 5 seconds. There are like lots of calculators out there that can tell you like, okay, you can have this many kilobytes of JavaScript, this many kilobytes of images, CSS, etc. And like that's the budget. You have to stick to it. If you want a new feature, it kind of helps to guide that conversation of, all right, well, what do we take out? We're going to hit our budget. If we add this, is there something we can take out? Is there something, a trade-off we can have? But getting all those different stakeholders, like looking at the same metrics, is a really key part of that process. So if you're just starting out with this, I definitely recommend starting with Web Vitals. In terms of having conversations with other stakeholders in your organization, I could probably talk for another hour about all the different ways to measure performance and benefits and pros and cons for all of them. Web Vitals is just, if you're not familiar, I'm sure a lot of you are, but it's what Google explicitly said, I think it was last year, that they use as a ranking signal in their algorithm. It's kind of like the most explicit they've ever been in terms of how does your site performance impact your ranking in Google search. And it's actually real user data. It's not simulated. It's coming from actual users browsing your site using Chrome, and it's like a rolling average over the last, I think, 28 days. So it's really about how your users are actually experiencing your site. And it's kind of interesting because, it really depends also a little bit on your audience. If you write a technical, news site and all of your audience is in Silicon Valley and they're using 5G internet and they all have the newest iPhone, they may have a much, the Web Vitals may be much faster for that site, even if the exact same site, the exact same technology is served in a place where the internet is slower and the phones are have less capacity. So it's really about the real user experience. There's a lot of data you can dig into. Google provides this in APIs. Also in your search console, you can get the most data about it. But yeah, so Google really chose these metrics. This is from a blog post kind of explaining it. To what they called out here is they chose it to purposefully organize stakeholders around a common goal by picking things that like really impact business growth. And actually, like Google's guide for getting started with improving web vitals, there's 3 basic steps. The first one is start measuring, like make sure you understand where you are. Step 2 is convince your stakeholders. Even before you get into like optimizing and everything, they really recommend you have those conversations with those other teams across your company and get buy-in that it's worth it for us to invest in improving our core web vitals. And that will necessitate some trade-offs, some and some really cross-functional work between teams. There's a couple case studies that I think are helpful that, about different organizations that have taken this kind of approach, set KPIs that they wanted to meet, implemented a performance budget, and really worked cross-functionally. So this one is from a German publisher, and they had like engineering, advertising, and product really working together. They wanted to improve their core web vitals. And the article is really interesting, and it really is a lot of like small tweaks over time. But really crucially, like the tweaks aren't necessarily something like the engineering team can just do on their own. So for example, I think one of the things in here was about, what is the I'm blanking on the name, CLS. The content layout shift. So, like the good user experience that Google is kind of defining, you don't want your page to, like the elements to all move around after it loads. So this publisher had an ad at the top of the page that it could load an ad that's like 250 pixels high or one that's like 70 pixels high. That's a really common pattern, but it can cause the content to jump. So, the engineering team, the ads team kind of collaborated. They removed an ad size so that it was, it only loaded one height, which is, kind of a scary thing to do. But they committed to experimenting with it, and they found like their CLS went to 0, meaning like the page does not shift. They get better core web vitals scores because of it. There's a bunch of other changes they made, and they actually saw like increased ad revenue and increased ad viewability over time. Another good example, I think, from this article, or maybe it was another one, where I think also with, that was for largest contentful paint. It's kind of a common pattern to have in an article template like a headline, and then an image, and then maybe like an author's byline, and then the rest of the content. The image is usually, Google tracks it as the largest contentful paint, and images can be like the slowest to load. So they just, kind of made a design. They worked with the design team, and they changed things around so that like when the article page first loads on mobile, it's all text. And you scroll a little, and then you see the image. But, like the text loads really fast, so then their LCP went down in the right direction. So it's really like those little tweaks that really require that kind of cross-team collaboration. And I pulled this as another example. YouTube also had to do kind of this like cross-functional work to improve their core web vitals. You might think because they're owned by Google's parent company, they like automatically have a really super fast performing site, or they're immune to this. And that's not the case. They had to really collaborate between the tech team and the design team to change like the layout of the video page. And again, kind of thinking about those core web vitals like largest contentful paint. What's most important for the user to see so that the page like feels fast. So again, another really good one to kind of read through for some ideas. So the last thing I wanted to mention, just in like the importance of making performance like a cross-organizational conversation, is I mentioned this a little bit already. Obviously, there's a big shift coming with the deprecation of third-party cookies. This is a screenshot from iOS, like Safari's already doing this. They've been doing it for a couple of years. Firefox blocks the third-party cookies. You know, it's a feature now that they like block those trackers from profiling you. So again, with the change, so once Chrome implements that, obviously Chrome has the biggest user base, so that'll really be effectively when they're no longer useful at all. But yeah, this is, you know, something that's going to require like coordination across a lot of different departments. So to kind of think about like, okay, what are those tags or trackers or technology that we have that's really based around that third-party cookie system that we can now get rid of? And that's going to have to be a cross-collaborative conversation with your advertising team. So yeah, it's just a really good, you know, kind of, it's a good time to start like having this conversation internally. You know, I've also, like the Washington Post, I see them doing this a lot. I work closely with some of their teams, and I think some of the things that help are like publishing, you know, the goals publicly in some kind of like internal space, having a process for when a change goes out, making sure the budget is set and they know, is this going to affect these metrics or not, and really just educating stakeholders across the company about like what benefits you could get from a faster site and like what trade-offs you might have to make. Yeah, so I'll pass it back to you, Fatih, to talk about tracking and monitoring performance.
Yeah, these next two tools we're going to talk about is going to be lighter, on the lighter front, compared to like what Sara covered. And we want to go back to, you know, page render dashboard a little bit. But under delivery tile, which is, it's not readable, but in the, you know, delivery tile, there are dashboards. These are the two dashboards we have. One of them is specifically designed for tracking your synthetic, you know, tracking your web vitals with synthetic tests with a, you know, underlying solution that we use, but they're synthetic. One of the things Sara mentioned is Chrome uses, or Google uses, Chrome collected real user metrics from real users, which is going to be significantly different than what you see in Lighthouse. So there's definitely a warning sign that, you know, when you run your pages with Lighthouse, don't freak out with the scores that you see, because the fact that like it runs on like, you know, low-end machines and simulated 3G network and things like that. So to do it right, you know, even though our dashboard still sticks with the synthetic tests with that simulated environments, just be aware of that. Like these data points are, you know, establishing the baseline and changing or tracking the changes over time. Going back to our previous session, that when you make deployments, when you make improvements, or when you introduce negative impacting, you know, changes, being aware that this is moving the needle in a positive or negative direction. So going back to page render dashboard, the majority of the metrics in the dashboard's main concern is not like real user or reader performance, but there are metrics that we collect that will be correlated with Lighthouse scores or the web vitals that you will be tracking, which two important ones are the edge time to first byte, which is directly in, you know, correlated with your time to first byte metrics. This is obviously the, you know, measurement that we see on the edge network. Real user metric is going to be slightly different, but it's going to be close, right? So I just highlighted the, you know, area that has like the, you know, the page size, and time to first byte metrics broken down by your home page, all the other pages, and your PF API calls. Having, you know, breakdown like this will also give you, it's not granular enough, because when you say like, you know, pages, it includes like article detail pages, usually lighter rendering, you know, pages, but also section front pages or heavier pages will be part of that you know, aggregated metric as well. But you can also use Page Builder render dashboard to look at like bigger time frames. I think, you know, a couple of our clients did look for like, you know, last 3 months or last 6 months time frames, because you may not notice a trend that is, you know, happening over time, that, you know, stuff that you introduce in your pages or your bundle may be slowly moving things in wrong direction. So you can use this dashboard to look at on larger window timeframes. More directly, related with our topic, page performance, we do have a site performance dashboard. It does pretty much like all of the metrics that Lighthouse produces. And you can, this is a sample environment, so we only have 3 domains included here. The reason, we want you to be aware of even though there's a single bundle powers all of your sites, your performance for each of your sites is going to be different. Depending on traffic size, depending on features or pages, published specifically for those sites, or the content is circulated specifically for those sites, right? If you have, multi-country operation, each country will drastically have different content in them, right? And that will impact the different and create differences between your sites. So this dashboard will give you at least simulated metrics to establish the baselines that you can stay on top of your Web Vitals. Yeah, this is the zoomed in view. You can do, again, look at long time frames, like multiple months or, like a year timeline. And as you see, we expose all of the Web Vital metrics individually. I think that's it.
Yeah. Cool. Well, thank you all.
Thank you very much.
Yeah, I think we're right at time. Definitely, like I said, please come talk to us after. Sign up for one of the ARC advice sessions. And, want to hear from you, do these challenges resonate with you? Anything else that you're, wanting any kind of support on? We really want to hear how things are going for you. So yeah, thank you so much. And I think now we have a 30-minute break and snack time.
Thank you.
Thanks.